Very excited to have everybody here. To kick off the afternoon sessions here, we've got a really great program. The topic on this one is smart fleets, charging software integration. I'm going to welcome up Yilun Su, founder and lead developer for Portify.
Thanks for coming. My name is Yilun Su. I'm the founder and lead developer at Portify, where we bring lightweight smart charging solutions to small fleets and destinations. And together with me, we have an incredible panel of experts in this field. And we're going to spend the next hour diving into questions, and we'll have probably 20 minutes in the end for a live Q&A. So with that, panelists, if you have all your microphone, why don't you introduce yourself and we'll get ready.
Sure. Okay. Hello, everyone. My name is Josh Aviv, founder and CEO of SparkCharge. At SparkCharge, we created the world's first mobile on-demand EV charging solution, where we actually bring the charging station to you with a push of a button on our mobile app or with the click of a button on our fleet portal. We service fleets as small as 5 all the way up into the hundreds. And we're super excited today to talk about how we are really revolutionizing EV charging here in North America and around the world.
Hi, my name is Raymond Kaiser. I'm with Evoke Systems. We're a charge network operator. We provide support for a wide range of EV chargers, pretty heavily concentrated in the Northeast, and a pretty comprehensive charge station management system offering.
Hi, everyone. My name is Eran Rosenfeld. I'm the Vice President for Drives. We are a software company. We started about 11 years ago and developed the operating system for large EV charging networks around the operations part of chargers, the billing, the roaming, white labeling apps, and dashboards, of course, and around the energy and how to cope with the limitation of energy as well.
Hi, I am not Lisa Marzrocco. My name is Damon Hahn from Multiforce Systems. I'm filling in for Lisa. I'm the operations director for Multiforce Systems, which is a fuel management company we produce hardware for tracking fleet fueling and integrating now EVs into the fleet manager's platform.
All right, thank you again, everyone, for being here, and thank you, panelists. So why don't we just dive in with some opening questions? I like to ask about the challenge. So the first question is about challenge. What are some of the biggest challenges in fleet electrification, and how can software help meet this challenge? So I guess we can just go around, and whoever wants to take the first, who can just go for it. I'm pretty sure you have a lot of things to share.
I think one of the largest challenges we see in fleet management is ease of use for the end user. I deal with fleet managers across the country. The more user-friendly a system is, your software system for the fleet manager and his team to use it, the more in tune they will be to use those tools. The harder it is, it's harder for them to adopt any type of new programming. So in my world of fleet managers dealing with ICE vehicles, people need time, they need their time, and to learn something new is hard. I'm not going to say change is bad, but if it's something that they're familiar with, they're more willing to adopt it and bring it into their systems.
I can definitely echo that. We see that with the fleet managers, you all of a sudden you're adding a new system, a new operating system. They got used to look at fuel, all of a sudden it's electric vehicles. And remember, the number one challenge is not necessarily, do I have the right amount of energy? Yes, no, the cost. I think that the first main challenge and the thing that they are looking for is, do I have the vehicle ready on time? That's the main concern. Because if the vehicle is not ready on time, forget about all the other costs. There's a huge loss, right? So that's number one, the continuity of the operation part. Then we see, of course, the struggle and the constraints with energy. Do I have enough energy on site to support the charging? Remember that the charging changes things. The grid, the utilities, the grid, the infrastructure not necessarily can support every site right now, right? So how do I cope with that? Looking at battery storage and other things that I need to use in order to cope with the energy on site and balancing the chargers and so on. We see also the drivers, the fleet drivers need to charge either at the depot, charging at home. Think about light vehicle, they don't have to go back to the depot, so they're charging at home. Who is paying for the energy? How do we compensate the driver for that? That's another area. Or charging en route, right? So either a depot, home, and en route, so all the roaming, the ability to just use the app or the fueling card, the RFID card to charge at home. Those are some of the main challenges, of course, that we see.
I'm really struck by the scale of the challenge. When you think about it, we take for granted how easy it is to fill up our truck or our car or whatever vehicle that we're using. As we really look to electrify transportation and we look at the numbers that people are looking at, it will actually be capacity at very distinct scales. So one capacity is really right at the panel. Do I put in a 400 or 800 amp panel? Will that support 20 or 30 or 40 charges, whether 10 kW, 20 kW, or larger? Is kind of the first tier of challenge in terms of capacity. The next tier is at the challenge at the point of coupling or the point of connection with the utility. So am I going to really limit the charging based on a set of rules in conjunction with the site load so that I don't have to upgrade my service? But the largest challenge, quite frankly, I believe will be at the distribution level. Because at the distribution level, I don't think that the utilities will really accommodate the kind of rapid growth that we will necessarily see as we electrify transportation. It's one thing to think about transmission voltage or medium voltage, and it's another thing to think about not everyone is a FedEx or US Postal Service. There's a lot of fleets that are actually in low voltage environments where the utilities will not accommodate one guy buying 10 Ford F-150 trucks. You think about a utility, they made a capital investment in an older industrial area 20 or 30 years ago. How ready will they be to add additional capacity? And that's really where software really can allow for a greater integration in regards to capacity. If we can not only look at load management or congestion management within the site, but across the distribution network. Right now, we're actually working with our national labs to develop a set of open APIs so that utilities and charge station operators and charge network operators can actually have visibility and collaboratively decide on how we can spread out these charging sessions, both to meet the operational requirements of the fleet manager, but more importantly, to not have to defer capital, to allow the deferment of capital investment or actually have a high utilization of the infrastructure that's already there.
Yeah, from our point of view, it's really about scalability and making sure that fleets can actually get a positive return on their investment. I think everybody in this room, if you've serviced a fleet or if you're working as part of a fleet, you've heard about the 2 to 5 year wait times that it takes to install a DC fast charger to service that fleet. With us, what we've seen is basically fleets like to grow and scale. No fleet stays the same size. Whether they start out at 5 and they ramp up to 50, or if they started at 50 and they ramp up to 200, they need to be able to scale, and infrastructure needs to be able to keep up with them as they're scaling to provide a cost-effective solution that allows them to continue to get a return on their investment as they scale and grow. And right now, our infrastructure just is not set up to service fleets in that way, and that's something that we look to solve day in and day out.
That's excellent challenges. I love to hear the more challenges coming. That means more solutions coming. So we touched on a little bit about, software in general. How can that help from your company standpoint? I want to push a little bit further. Can you show us the success stories, right? Success stories that solve maybe just one of those challenges, right? Because that way we can relay to our maybe specific use case. Maybe you have a product, maybe you have a service, maybe just an idea, or maybe it's from your peer or anything. If there's a story.
You want me to take it?
No, go.
Josh.
Start at that end.
Oh, okay. So right now, Con Edison has a really significant challenge. Here you have a city where they've banned natural gas hookups, where they've shut down power plants on the island of Manhattan, and where it's typical, they'll knock down a 20-story building and put up a 40 or 60-story building. So one of the things we have about 1,100 chargers within Con Edison's territory. And one of the things that we're doing is we're mapping out. Con Edison is broken out the 5 boroughs in Westchester County into 82 zones. And what we're doing is we're working with, as I mentioned earlier, with Argonne National Labs to basically provide Con Edison with real-time visibility in regards to charging in each one of those zones and the ability to do a short-term forecast, and then with the cooperation of charge station operators to basically be able to dial down the load. You know, if you think about New York City, it's a fairly complex mesh network. And so you have an overloaded feeder, or you have a fire in a secondary substation, and what's the ability to do switching operations in coordination with charging activity to actually provide enhanced reliability and resiliency? And clearly fleet depots and operations, because some of the fleet proposals that are going into New York City will be very large load centers. So this capacity to have situational awareness, real-time visibility, and the capacity to dial down as needed or to support switching operations in a mesh network becomes a very powerful way to ensure that as we electrify quickly, that we don't cause unintended consequences within the local distribution areas.
Happy to share some of case studies and scenarios that we saw. As I mentioned, we're working already over 10 years in this industry, and we are obviously a little bigger in Europe. As the US is lagging behind, I would say, a few years after Europe, so we have a lot of examples. Yeah. Some of them are, and we have sometimes are presenting a real data, how the software can help fleet in terms of energy cost, for example, right? Which we know it's a big challenge. So you can connect several vehicles to the chargers, but not necessarily start charging them automatically, right? Because if you have the right integrations, you know what is the route, when the vehicle need to be ready, how many miles they need to ride today, and so on. So you have that data. We also can get the data of the time of use, the rates, the cost of energy during different times of the day, and some other parameters that are built into the system. Then the system can actually assign those smart energy policies. So we saw a situation where the 4 of the cars connected to charger, only 1 vehicle starting to get charged, but not from the grid, from a battery storage that is on site, right? Then at 10 a.m. or whenever the cost of energy drops, then the rest of the cars or all the cars are continue or starting to be charging from the grid now, right? The vehicles are ready on time because we know when they need to be ready, right? And in this specific case that we show, we see about 23% cost reduction on energy. So that's big, right? The other thing that we see, and especially in California, we have already project with school buses electrification. Those are fleets, and we know those will go fast here. There are about 500,000 buses, school buses in the US, and started to be electrified. And we see over there that in California, again, the cost of energy is very high, so they need automation, right? They need automation that do not start charging before that and that time at the evening and so on, and not necessarily fully charge, because I know how much they need, etc. It's all have to be managed by a smart software, of course, platforms, because otherwise you cannot scale. If you want to scale, look at the cost of energy, we need to do it with automations and softwares.
Sure. So I think when we think about some of the success stories that we've had at SparkCharge, the one that always kind of like sticks out to me is we work with a micromobility fleet that needed to have cars charged on both coasts. So they need to have cars charged in Boston and they need to have cars charged in LA. This fleet had never really deployed electric vehicles before. This was their first electric vehicle. They started out with 1 car. They didn't know if their customers would like to use electric vehicles. They didn't know if they were going to be able to charge electric vehicles, but they knew they wanted to try. And so they started out with 1 car in Boston, and then within 2 weeks, we were able to ramp them up to 2 cars in San Francisco. Within a month, they're already now approaching 20 cars across both coasts, and we're on track by the end of the year to bring them up to 700 vehicles by the end of the year in their fleet, fully serviced. And this company has never had to install 1 single charging station, yet they are now on track to ramp up to close to 1,000 vehicles by the end of the year. When you think about it, one of the things that we see as a big success is the fact that we're able to help companies grow and scale their fleets at a time and a pace that EV infrastructure just cannot match. Mobile for us is really the solution that's unlocking the ROI for the fleet customer, but also unlocking the scalability. And so when we look to those success stories, that's stuff that we're extremely proud of. The fact that we can be mobile, service their vehicle across Tube Coast, all at the same time and help them scale.
Excellent.
I think one of the ways software helped us, as we are a software and a hardware company, is we were able to use software and convert dumb chargers into smart chargers, which enables our customer, our fleet owners, convert their fleet a lot quicker on a more affordable basis. Where our biggest success story right now is Princeton University. We've deployed over 162 Clipper Creek chargers where we're actually gathering smart data from them using our platform, communicating to one or two of our terminals. So the ability for our software team and our electronics engineers to develop this and use software, use things like open APIs that we're going to be pulling demand and peak charges from so we can do that throttling back. And if we can do that over the course of using dumb chargers and converting them into smart chargers through software and through our engineering team to make it a more reliable product has been very crucial to our fleets. Because if you think about it, our fleets is not going to be gas stations where you do a pump and do fast charging for 120 vehicles. It's just going to be crazy. They're going to want to do more slow charging like they've been doing the CNG slow charging. Slow fueling. So we're looking at a parking problem for these fleets to where you're going to be having 100, 260 vehicles, and to spend that kind of money on very expensive chargers is going to be, it's going to be a hurdle for them. So enable for us to be able to dumb down the technology and convert it using our platform and be on the same platform for our fleet managers has been, it's been a driving force with our community, within our company to keep this project moving forward.
Those are excellent. A lot of new things for me too. So glad that I got to hear it here. So now let's switch, not gear, but voltage maybe, to talk about cost and what if that doesn't work. So the question, or maybe another challenge for the panelists is that, can you talk about how do companies address upfront costs and operational disruptions that come with these software integrations or installations?
Yeah, I can start. Again, we're coming from the software part of things. I think that when I see the overall picture for fleets, buying the vehicles, right, the chargers, training, and so on, I see the software as a little cost in this bucket. But again, it's still a cost, right? It's still a cost. I think that the NEVI funding and other programs help with the cost of software as well. We see that. One of the things that we're trying to do as a software to help with cost is to be very agnostic. We are supporting over 750 types of chargers. So as my colleagues mentioned here, DC or AC, depends on the application and so on. So being able to support that, allowing the fleet the flexibility to choose the right charger. We would like to say these days with the standardization, as long as they are OCPP, of course, it's great. But even there, if they're not, we can cope with that. That's something that we see. The other part of cost, of course, that the fleets should look at, of course, is the operation, as you mentioned right now. The operation, it's a new operation, new skills that need to be educated, need to be trained for the fleet. Some integration cost. Integration is very important. You cannot be just a software that manages the software, the charger, standalone. But what about integration to telematics, integration to fleet management system, to legacy software, etc.? Those are also part of the cost. I recommend to be smart about it. We are at the beginning of this era right now, and we don't have to go all in, from day one. So to plan that part of cost as well.
I agree with what you said, that the software cost is a very small portion of the overall system cost. And certainly the cost of the vehicles, the infrastructure, the make-ready cost, all big things. But to me, the issue is really not about cost when it comes to software. The real issue is about value. you think about, you can go out and buy a phone, and what it does is it makes phone calls. But guess what? You add software to that phone, and all of a sudden you have unleashed a lot of value. And so ideally, a software platform and software integration really unlocks a lot of the value, whether it's authorization and authentication of the drivers, whether it's that some drivers are going to be fee-based, where you're going to charge for people to charge their car or not. The analytics that can really provide for real clarity about what's happening with the chargers, what's happening in terms of the ESG reporting. So it's really the software is not a cost. The software is a way to unleash the value. And the more clarity you have about the operational considerations, the regulatory requirements, and the analytics that actually can create value for your organization, the more you will not see software. I mean, I don't see Microsoft Word or Gmail or email as a cost. I see it as an unleashing of value. And so for me, it's not a cost issue. It's a value equation.
I think one of the costs that some fleets are running into is training. If you think about your technicians, your fleet managers, your people that are actually using the equipment, are they getting the proper training? Now, I'm going to steal somebody's comment that they made yesterday about this. And what they said was, buy the extended warranty. And I'm like, wow, that was a mind blower, because you're buying that extended warranty and they're using that for training. When they do have issues, they have the ability to get their technicians, to get their people who are using the equipment trained on how to fix it, how to operate it, how to maintain it. And I think that is also part of something that's going to help with the costs, is to be self-sufficient as a fleet.
Yeah, from our standpoint, one of the things that we look at when it comes to the software, we give it away for free to our clients, right? So you can use our fleet portal, you can access your vehicles. We don't charge anything for it, simply for the fact that our goal is to make sure that you as a fleet owner don't have to worry about charging. So when we think about software and we think about the cost savings, one of the things that we look at is how can we remove you charging the vehicle out of the equation. One of the ways that we've been able to do that is sometimes our fleet software can actually tap into the vehicle. So we can see the state of charge, we can see the location of the vehicle, and we can actually dispatch range to that vehicle on demand. We call it auto charging, which means that you as the fleet manager don't have to worry about ever touching another charging cable again. Right? We show up, we know where the vehicle is, how much range is inside of it, and we automatically dispatch range to it through the fleet portal. So this means now you've saved time and cost as a fleet manager, not having to worry about how many cars are in my fleet, what's the state of charge, how many cars need energy, where are they located. We can manage that for you, which means you have a significant cost savings in terms of how you're scaling and growing your fleet.
I'd like to add something and just to chime in that part. I think that fleets should look at the values, as you mentioned, that are coming with the software. If the software help you to save on energy cost, for example, it's definitely way more than the cost of the software itself. If the software will look at the time of use and determine when to charge, how much to charge, as opposed to just charge, right? There you go with the saving on cost over there. We as a software developed a self-healing mechanism. So those are the tools that help making sure that the charger is up and running all the time, right? We solve about 80% of problems automatically. So there is some saving for field technicians and other costs. So we need to look, I totally agree with you guys, need to look at the value that the software will bring in order to cope with the scalability and flexibility that is needed in this market.
Excellent, thank you. I want to push a little harder on the what if it doesn't work part, right? So the most common comments I've heard over and over again over the years, and especially for the past 2 days, is, okay, so you're adding another software platform. I've got 20 already. So what if this is just another software platform? And the professional way to say it is, what's the interoperability between or among these softwares? And more importantly, what if yours stop working or start to affect others or disrupting other business processes? What are you gonna do? So maybe share a little bit ideas or maybe examples, or maybe what you feel like the future should be. Maybe just 1-2 sentences on that front.
Okay.
I can start. Coming from the ERP world, the ERP and CRM, if you're familiar with the terms, the SAP and Oracle of this world, definitely look and make sure that the software layer that you're adding is reliable, stable, debugged and so on for sure. Then you definitely need to look at the openness of the software. These days we understand that we need to be open. My colleagues here mentioned APIs and other in order to connect and interface with other softwares and so on. But it's like any other software project, if you will, that you want to make sure that you do the right integration, the right testing, and making sure that there is a seamless experience with the software, and the software is flexible enough to support the future. Some of the things we see right now, some of them not yet, right? So if you're working with a maybe closed system, closed network, you need to be aware of that, just making sure that the software is integratable and can grow with the business as you grow.
Yeah, I agree with that. I think most softwares today should have API ties. I think one of the things, if you're building a software platform, it needs to tie into as many systems as possible and be as flexible as possible. I think, when we think about all the software that's on this stage, everyone here acknowledges the fact that businesses are all different. But when it comes to servicing your fleets and tying into those APIs, we have to be flexible as well.
I'm going to take a little bit different stab at the question. Really we have a gold standard for reliability, and it's actually being set by Tesla. Now, we don't sell Tesla, we don't plug into Tesla, but really the expectation that it should be really, really simple, it should have very high reliability. The industry is still relatively immature. And it's not just a software issue, it's a backhaul communications issue, it's a field service issue. A lot of the people who are putting in the chargers have a real diversity of understanding and experience in terms of designing and putting in charging stations. So my not caution, that's probably not the right word. What I just recognize is that we're still early in. I was involved early in on the PC industry. And there's a natural, and I like what you said, that Europe right now is well ahead of the US, because we're seeing the good, the bad, and somewhat the ugly in regards to the market maturity, whereas in Europe, I know that they're further along in terms of dealing with a lot of the inexperience and a lack of core competencies in terms of delivering reliability to end users.
Reliability has been a key term that's come up, especially on day one. At the sessions on day one, a lot of the fleet managers, property owners, reliability and uptime is absolutely one of their highest concerns. And I think that breaks down to technology. What technology, what platform is your charging system using? I know with our system, we're using a much older technology. We're using RS-232 to communicate with charge. It's a tried and true, it is a reliable, bulletproof method of communication. And on the software side is, our system can actually not communicate with the network or the host software for probably 6 or 7 months without needing to, and your end user operator that's charging out on the fleet can still operate, and they'll have no clue that the system's not reporting back to the mothership. So knowing your technology and how it works and having a good staff, which I'm sure we all do, that support our equipment is key.
Excellent, thank you very much. And let's come back to the cost a little bit. And maybe dive deep a little bit more. So I want to ask the panelists, how can companies effectively balance the cost saving and environmental benefits of implementing charging software system? So this is, when you cut cost, what do you cut, right? So what about the environmental benefit that initially come with, building EV chargers and wanting to do help with climate change, but then in the face of cutting cost, how do you balance those factors?
Cutting cost is basically what fleet managers do. They're chasing that penny, they're chasing that dollar. Their end game is, what is my cost per mile, per vehicle? What software does, especially with the electric vehicles, is it's cutting down your annual maintenance per vehicle, probably about $4,000 a year based on your oil changes, air filters, that sort of thing, brake pads. With electric vehicles, your maintenance cost is down. How software does it is being able to use gasoline gallon equivalents, so your fleet managers can determine what their annual cost to operate that vehicle. So switching over to electric vehicles from ICE, you're able to cut your user costs down, which in turn gives you the capital to invest more in your charging network, your micro networks, and your fleet?
We need to be smart about when we're charging, how much we're charging the vehicle. Be very smart, very accurate about it. That's why the software might help. And there's another saving, another cut on the cost over there, right? We need to look at the other energy, call it the bigger energy picture here. Something that we'll see not only with the time of use, the different cost of energy, right? But also to participate and support the grid and balancing the grid. And this is coming. We see it in Europe right now, the demand response. We see it coming to the US as well. There is a monetization over there as well. And maybe it's too early, but fleet should look at that. The carbon credit and the monetization out of supporting balancing the grid. Here is another factor of saving costs.
Yeah, we look at cost savings holistically. So we look at it from the standpoint of, can we save you cost by not having to install infrastructure? But then can we save you cost from also removing a lot of that wasted time that comes with managing and trying to charge multiple EVs? We also look at it from the standpoint of where we get our energy from. If your fleet is located in, downtown New York City, all right, well, do you need to purchase energy at a premium rate in downtown New York City? Or can you purchase energy further out and bring that energy in at a lower cost, which means that we can effectively pass on that cost savings to you, right, no matter where your fleet is located. And so when we think about it, it really starts, from basically how many cars are in the fleet, where are they located, are we saving you cost on the installation, are we saving you cost on the time, are we saving you cost on the energy, and can we make that a holistic solution that makes it easier for you to grow and scale? One of the things we even started to look at was a lot of fleet managers, and you talk about like managing the penny, that's so crucial. A lot of times fleet managers are even spending money on like cleaning the vehicles, right? We opened up currently car care in select markets where while your car is charging, our technician can clean it as well. So now that means that we've also saved you an additional dollar amount by not having to spend money on cleaning and wasted more time taking the car from the charging station to the depot, to the cleaning, and then put it back into service. When we unhook from the car is turnkey ready, and you can essentially now put it right back out on the market, saving you time, energy, and money.
It's a great idea, by the way.
It's a good one. We opened that one up.
It's a very good one.
It's a good one.
And this is exactly what we don't know about this industry.
Yeah.
And it's coming and we're learning right now. I just learned.
Yeah, it's a good one.
I'm actually been wondering when it's going to come down the pike. Is with electric vehicles, what are we not paying? When you go to the gas pump, you're paying road tax. Pretty soon, Uncle Sam's going to want his cut because now the streets are going to crap because, you're not paying the road tax, they're not getting the funding. I think software is going to play a big deal in how to calculate for Uncle Sam to gather that road tax money. So if we're using a good software program to track that, you as fleet owners can either get accurate numbers instead of over-guesstimating and paying more than you actually should.
Sounds good. Thank you very much. I just want to add a quick comment there. We use the word software, but there are a lot of things going into the software. You can build an app, you can make a website. Those are softwares. You can make a PC, Mac versions. You can make anything that is called a software, right? So what I want to highlight is the interoperability. Having the reliability, and you can switch between the platforms. You can integrate with APIs. Those are crucial. Right? It was crucial, and it's more than crucial right now because how many charger vendors out there here. If you are an owner operator, you're gonna end up with multiple brands, multiple platforms. They better talk to each other. They better talk to your existing system, right? And back to the environmental factors, different software does different things because in the end they need to make their business work and they need to focus on what they have. That means none of the software is going to have all the functionality you need. So back to the interoperability, you're going to end up with multiple apps on your phone, multiple systems. The ideal word is that they are compatible, right? They work together to derive even more value to it. So I guess that's me chiming in, and I feel the excitement from the room already. So why don't I pause here and let the audience ask questions to the panelists from what they said? Was there any clarification needed? Or do you just have a question for, software, fleet, smart charging, those things? There you go. Is there a microphone delivered? So that gentleman over there. Yep.
Hi, I'm from the city of Phoenix. I'd like to know from the first gentleman on the panel, you said you were going to go from 20 to 700. How are you doing that? Are they going to do home charging? Are you setting up an infrastructure project? How are you getting there?
Yep. So we manufacture all of our packs here in the United States. One of the things that you guys will be hearing about relatively soon, here in the next couple of months, we just opened up a brand new manufacturing facility. We'll be producing upwards of about 300 gigawatt hours of energy out of that facility in Buffalo, New York. That'll make us the largest producer of energy going into electric vehicles in the United States. It's something that we're extremely proud of, and it's really built to help scale with our partners. So when we think about that one particular partner that's going from 1 to 700, really what they're doing is they're rolling out in clusters across cities across the United States, and we're there to help scale and grow that fleet once they get there. So for example, in LA, where they started out with 1 car, now ramped up to 20, they're going to be spreading and doing that in pockets across the United States, and we'll be there to basically get them up and running and scale into the future.
Best chance to ask a question. Otherwise, I would. Sounds good. So why don't we talk more about, the basic concept of time of use, right? Demand charges. Those are the basics of, I'll say, the start of the smart charging, the main reason for it, right? So maybe money side of things too. So what is time of use charge? What is demand charge? And how can software take advantage of that and save costs and derive other benefits?
Yeah, the way that we look at it, in some markets, we start charging cars at 3 a.m. and we run all the way till 1 a.m., right? And so when we look at that demand charge and we look at that profile, one of the things that we look at is, okay, well, where is the energy the cheapest and then where can we get it? So when we think about demand charging, if we're charging your cars at 3 a.m. and we're running through your entire fleet, charging cars every day all the way up until 1 a.m., we can draw energy from certain parts of the city that are most cost effective and then pass that savings on to you.
The way that we looked at that, and some of our customers are already rolling that, and we enable that as a software, is the ability to load different cost of energy, time of use, dynamically into the software, and then roll it to the customers and so on. One of the things that we see at fleets, when they have that cost in the system, in the software can apply, smart algorithms in order to decide when to charge a vehicle. That becomes more and more important in this case. And the other part is the demand response. We see that as well, especially in Europe, and it's coming here to the US, where fleet, when they have enough energy, can support the utilities. The utilities will sell the signal, so we are enabled an open ADR, automatic demand response signal, to the fleet. If it's a large fleet, large amount of energy, can decide to lower some of the charging capacity. We can do that by sending automatic profiles to each and every charger in the network and so on, and therefore participate in the demand response and the flexibility market. And over there, we are talking about nice amount of dollars and saving and monetization for the fleets.
Using things like open APIs to gather information from your local power companies, which will give you your rates, your demand, and peak charging times. Using your software, you can actually do your timing for lockouts. So even though I know in our system you can plug your car in, authorize your transaction, have your vehicle in there, and then you can go to work and it's going to say, hey, this is not the right time, but while you're still at work, it'll kick on when the rates go down. So using software to control the timing of your charging and have the end user or the customer not have to worry about it's 2 o'clock, let me run out there and go plug my car in. We're having the software manage that for you is another way to control it and keep your fleet going.
It's interesting. we support time of use rates. We support really accommodating demand charges, but that's looking backwards. And what I mean by that, by looking backwards, if you think about the purpose of time of use rates and you think about the purpose of demand charges, they have two different purposes. In the case of time of use rates, you're trying to establish the time value of energy. In the case of demand charges, what you're trying to do is you're trying to appropriately allocate a capital cost to those people who are basically using a lot of juice when the system is not well designed to do it. The challenge with how we're currently doing it now is it doesn't really take advantage of the fact that the devices today are much more flexible than they've been, and at the bulk power level, we're moving from dispatchable resources like coal, nuclear, and natural gas to non-dispatchable resources like solar and wind. Now, how does that actually play out in the real world? So if you look in Southern California now, in the spring and the fall, because so much of the generation portfolio during those times of year is solar, Southern Cal Edison actually encourages people to charge during the day. And that's a great idea, because in the spring and the fall, they have a lot of solar, they're not running a lot of air conditioning. The challenge is that's the same time of year that they take their dispatchable generation offline to do maintenance. And so they're producing a lot of solar, and all of a sudden there's an unexpected weather event that comes in, and all of a sudden you don't want to encourage people to charge their car during that time. You want to drop the load quickly. And so that's why the traditional time of use rates don't work well. Now, the same thing works in the Midwest. In the Midwest, at night, which is when we have time of use rates that encourage charging at night, 70% of their generation at night is wind. And that works great because wind is cheap. And guess what? Most of the Midwest uses wind at night, and sometimes you'll have a precipitous drop in wind energy, and you're encouraging people to charge. And so really what we need to do is to move away from a static model in regards to energy, both in terms of capital, deferring capital investment, and also the time value of energy, to one that's really based on these solid-state electronics that can respond very quickly to the stochastic and natural variability of renewable resources.
I want to just chime in and to add that we'll probably see more and more battery storage in play since the fleet locations not necessarily will have enough energy to support. And in order to cope with the time of use, just imagine, battery storage in place, integrated with the same software that we're all looking at, charging at off-peak hours, low cost, saving this energy, harnessing this energy, and then use it in different peak hours and where needed. We'll see more and more of that. And again, this is another example of integration that is needed in order to scale.
There was a question over there.
It's almost a continuation. How long before the vehicle manufacturers will make these, how long before they're required to make these dispatchable and have the vehicle-to-grid technologies in order to be able to sell and arbitrage energy and use the vehicles as resources, grid resources?
So I'm a really big skeptic on V2G, personally. I think it's way oversold. It is not a magic bullet, and there's a lot of problems with it. What I would say, now I live in Florida, and I went through Hurricane Ian. You may or may not have heard of it, it doesn't matter, but I was without power for a week. Now, when I was without power for a week, I had 7 kilowatts of solar on my house, and I had 75 kilowatt hours of energy in my car, but I couldn't use it. And so rather than vehicle to grid, I really believe that vehicle to business, vehicle to home is a much more doable venture, and I think that that's coming. And it will be driven by really folks like myself that says, why can't I use these batteries in my car to support my refrigerator? And I think the vehicle to grid is more likely to happen grid at point of common coupling. So you'll have larger fleet operations that'll have on-site storage, they'll have generators, they'll have stationary batteries, and the business proposition around establishing transactions between fleet operators and grid operators is much more likely to mature as a market than someone in their house with a Tesla or a Volkswagen ID4.
I would add to that that I agree. We see the V2G, the vehicle to grid, but some people are already using V2X, right? So the vehicle to battery, vehicle to building, vehicle to home, and so on. And I think that we'll see that. We already know that some companies have batteries that you can install in your garage and then support your home. So why not doing it with a car, right? So I think that we'll see more of that. We already have project in place supporting V2G, mainly in Europe, but also in touch with utilities as they are getting more and more interested on going to pilots for V2Gs as we speak right now. So
Sounds good.
This, this question is for the three gentlemen who has a software platform. You guys be collecting loads of data. How do you guys see collaborating between each of you and use the data for the good of the industry while competing?
I totally didn't understand that. Go for it, yeah.
I don't know if it would be a question for me or not, but I'll. The software people, all right. We collect data. The way that we work, we are a cloud platform, SaaS, software as a service. So the data that is collected basically owned by our customers, right? We have customers like EVgo, Circle K, using our software as a backend. It's their data. Start with that. And I'm sure that you can use the data to look at statistics, where people are charging, there is a utilization, where to place next charger, energy aspect of charging, and so on. And it's up to the customers to decide, how to support the industry. But I'm pretty sure that they will publish articles and, other white papers to support the industry.
I think spreading the load of who uses the software for what purpose is also where I think you're getting at. So where your fleet manager is going to be looking at your vehicle data, your facilities manager might be looking at time of uses, what chargers are up and running, so they can both have equal access to the system to gather the information that they need. The maintenance facility people, they probably don't care what vehicles are charging. They just want to know how much is being charged. So I think sharing the load collectively as a team on the end user side is where software is going to come into play, where everybody can help each other out.
We have a pretty strict privacy policy, and based on the data privacy policy we have, like you said, the customer owns the data. So we would not readily share the data with others, and we do share data with others. So part of the privacy policy is that when a customer takes advantage of a utility grant or they take advantage of a state rebate, really oftentimes there's a reporting requirement where we have to anonymize that data and make it available to a third-party agency that may represent a utility or a state agency. Now, the odd thing about the data that we currently provide, they're asking for very detailed information every quarter. And because we're providing it every quarter, the usability of that for distribution operators or for real-time analytics is really deficient. And so for me, both within the context of providing privacy to our customers, whereas at the same time providing the usability that others could really make use of in terms of actually improving grid operations, there's sort of there's a significant gap.
I think there was a question somewhere here.
Hi, this is Srinath from Amazon. We are working with fleet charging to kind of electrify the last mile operations. When it comes to software, one issue we see is is in terms of connectivity or in terms of reliability of connections to the network. Is there an advantage by moving a lot of software operations to control the fleets or the vehicles directly through telemetry rather than trying to control the chargers itself?
Yeah, I think from our end, we definitely see that, right? The more connected the vehicles are to the actual software, the more efficient you can be in actually charging them. And that means that your fleet customer is actually going to get that value passed along to them as well, and cost and time savings. So I think the more that we start to see vehicles come more connected, and I would even go a step further and say the more that there's one central source of truth for vehicle connectivity that can tie in to all of the software, right? We'll see actually even more efficiency when it comes to EV charging and tracking.
One thing I would say is that the U.S. car industry is known to bravely go where everyone else has gone before. I don't really see a lot of leadership on the part of the. I don't want to speak to other, and not to say there aren't exceptions, but in terms of the traditional automotive manufacturers in the U.S., they're not leaders, and they will try to basically take a slice of the pie. Certainly, there are use cases where connecting telematics is an important value to fleet operations. So I'm not trying to diminish telematics, but if you think about the wide diversity of fleet types, from large transportation and logistic companies to institutional players or service industries, of the local delivery companies, the waterfront is so wide that my belief is at the point of the person paying the electric bill, that's where the information is most readily available, most valuable, and again, that's a personal opinion. And as you know, there are so many different use cases, and I'm really kind of just telling you my own little bias in regards to where I would look to the source of truth. Like you were talking about.
From our conversations with partners, organizations that are working with the OEMs, we see more and more OEMs, car manufacturers, getting into providing more data that is available via telematics and others. We see that definitely happening right now. And then when you combine the data, as Josh mentioned right now, so you have the data coming from the charger, you have the data coming from the car, then everything is available and everything is open. The other part that you can see, of course, happening, that the OEM starting to support more and more plug and charge, ISO 15118, that we support already enabling, but you need the car to support it, the charger, and then the software. So we see that in some parts of the world, a little bit here, that coming as well. I think that the OEM understand that they will need to support it, because as soon as you have the state of charge and some other data coming from telematics, etc., you have more predictability, more analytics available.
Yeah, I think you're discussing like vehicle telematics. A lot of our customers with their new vehicles, Volvo, Freightliner, the big trucking Peterbilt, things like that. Our customers are starting to move away from the old ringy-dingy and technology of yesterday and integrating telematics. I know Mike knows what I'm talking about. Things like Samsara and some different GPS telematics that are getting the vehicle information where we as fleet management companies, we no longer have to spend the energy coming up with these fancy ideas on how to turn things on. We're able to integrate and work with different customers, telematics companies or their vehicle companies, and bring their data in or push our data to a common fleet management type program where everything comes together there and they're looking at one source and everybody's just one part of the puzzle.
I'm going to modify my answer a little bit based on, based on what I just heard. It is clear that the auto companies realize that they have to stay in the game. It is clear. And again, I don't own any Tesla stock, and I run hot and cold on Elon Musk, but it's no doubt that he has really repositioned a vehicle as a software product more than a hardware product. And, it's why they displaced the CEO of Volkswagen, is because they weren't quite getting software right. So I'm going to modify my comment, soften a little bit based on your feedback, and realize that everything is going to come together. Everything at some point will be interconnected. So yes.
Is that allowed to modify answers in a panel?
I was actually going to do that. I'm going to go a step forward because we're a tech company. We look at this data availability today as that, a certain data, you can get it from multiple sources already today. For example, the charging data, for example. You can get it from a vehicle, you can get it from the charger. You can get even from the plug itself. So the way I think about the source of truth is that, which one of the source is the best source to get the data from. I need to pick that, right? Oftentimes this comes down to cost, right? It's costly, to be honest, to get data from vehicle because the vehicle is meant to be driving, especially it's on a battery. It's less costly to get it from charger, in that example of charging data. So that led me to think, going forward, we're gonna be overwhelmed by data with multiple data sources. It's really about integration and picking the right data source, right? I'd love to have a single single point of truth, but the reality is I have multiple points of truth. I need to pick one, the one that is most useful, reliable, and maybe cost effectively. So that was a great question. Anything else?
How are we going to integrate EV chargers into building automation systems? Because right now they're a bit of data silos, like, yeah.
When we do load management, we can do it at the charge station level. We could do it, and a single site might have a single charge station, multiple chargers on a charge station, but might be multiple floors in a garage. But we could also integrate with another source of truth. So you could put a sub-meter and/or building automation system that can basically create the threshold constraint condition that you want to establish. So whether you do it with a building automation system, whether you do it as a sub-meter at the point of common coupling with the utility, and/or whether you do it with the utility itself, we're kind of indifferent to where's the constraint condition coming from.
In the OCPP 2.0 and even the upcoming 2.1, the main, if not only, improvement from the last version is the local smart charging or local load management, meaning it allows a local device, in addition to the charger, to handle additional source of truth or source of energy. So basically, if your building is smart building and it can provide that kind of data and take input, and it can be easily integrated with the current standard protocol. And that standard protocol, everyone here is based on. So I see that as a future, just having the protocol updated and then being more open to other things that might be beneficial to the entire ecosystem. So that might be something you want to look into.
By the way, OCPP 201 is already here, of course, and some of the software support, we support it.
Yeah, so 201 is here. I was talking about 2.1, so that one is highly confidential, but it's coming soon. So if you advance into that space, please look into that. We got about no time left, so we're here. So thank you very much, everyone. Exciting moment, exciting session. Thank you, panelists. Delightful to be here, and we'll stick around if you have questions. We're happy to be here. So.